Hi, welcome back to LeetCode. So in this video, I am going to discuss LeetCode problem 3546 equal sum grid partition 1. So you are given an m cross n matrix grid of positive integers. Okay, your task is to determine if it is possible to make either one horizontal or one vertical cut on the grid such that each of the two resulting sections formed by the cut is non-empty, and also the sum of the elements in both sections is equal. We have to return true if such a partition exists, or otherwise we have to return false. Suppose for this example 1, our matrix is look like first is 2 cross 2. So first is 1 4 2 3. Suppose what actually partition actually we can do, this is non-empty. So what here so they mentioned that each of the two resulting sections from the cut is non-empty. So one possible cut is here, horizontal cut here. So this is first, this is second, and this is third. First we'll check that is this cut is valid or not. So first cut is valid or not? Not valid. Why? The first condition is not satisfying. That we have to after cut after result the two resulting section formed by the cut, it should be non-empty. But if I cut here in this line 1, so this will be the section 1, and this will be the rest section 2. So you can see here that section 1 is empty, but here we should actually have both are actually non-empty. Whatever the section, actually two section will be there. So this is not a valid cut. Next is 2 is a valid cut. Yes. Why? Because this is section 1 and this is section 2. Both are actually non-empty. But now we have to check that the sum of the elements in both sections is equal or not. So this is section 1 and this is section 2. So for the section 1, what is the number actually element are present? 1 and 4. So sum is 5. Next, the section 2 will be sum is 2 plus 3. This is 5. So both are actually equal. So we can see that this actually returned true. We don't need at least if at least one valid card is present, then we have to return true. Correct. So that's why we can actually return from here. Now we can explore other also. Like first we will check that this three section this cut line number 3 is valid or not. This cut not valid because this will be the section 1 and this will be the section 2. Section 2 is empty, so this is not a valid for the first condition, not satisfying. Correct. Next, for any other cut, actually the vertical cut, this is for horizontal cut. So vertical for 1 4 2 3. This is the matrix. Now what is the vertical cut actually we can do? First of all, this is the one vertical cut, this is second, and this is another vertical cut. So this is first vertical cut, this is second, this is third. Okay, now we have to see that this first vertical cut actually valid or not valid. Why? Same reason that this will be the section 1 and this will be the section 2. Section 1 is empty, but we should actually have that both are actually non-empty. So this is not a valid cut. Next is 2. 2 is valid cut or not? Yes. First of all, we actually have some section 1, some elements in section 1, and some actually have some elements in section 2 also. So first condition is satisfying that both are actually non-empty. Now next condition is that the sum should be same. So what is the section 1? Elements are present 1 plus 2. The sum of this element is 3. Next in section 2, how many actually are present? Again 2. So sum will be 4 plus 3. It is actually 7. Both are not equal. So this is not a valid. Next is 3. 3 is a valid? No. Why? Because section 2 will be empty. In the right side of this, there is no element in this section. So that's why this is not a valid cut. Got it? So we have found at least one valid cut. So that's why we have to return true here. So that's why here the return output is true. Got it? Similarly, for this example 2, you can see here the matrix is 1 3 2 4. Correct. Next, first of all, check is there any horizontal cut which is possible or not. So this is not a valid horizontal cut. This is one possible, but we have to check that sum is equal or not. Next is this is another vertical cut which we can do. So this is not a valid, and this is also first and third is not valid. I've already mentioned why. Next is if I for this 2 line number 2, is it valid or not? How actually you can do? So what is the section sum of the elements in section 1 is 1 plus 3, it is 4, and sum of elements in section 2 will be 2 plus 4, it is 6. So both are not equal, so this is not a valid cut. Next actually what actually we can do, we can do the try for vertical cut. This is one vertical possible vertical cut, this is another, and this is another. So I've already mentioned that this first and third vertical cut will not be valid. So this is only one possible valid cut. Now we will see that after this cut, whatever that we will found two sections, section 1 and section 2, left section and right section. So we will check that sum of that section. So in section 1 sum is 1 plus 2, this is 3. Next is sum for the section 2 is 3 plus 4, it is 7. So both are not equal. So we have not found this is not equal, so this is also not a valid cut. So we have explored all the possible vertical cut and horizontal cut, and we have not found any valid cut, so that's why ultimately we will return false. Got it? Now what is the brute force approach we can think? So we actually have some matrix. Suppose for this matrix 3 cross 3, suppose 3 cross 3. Okay, what actually we can do? We know that our horizontal cut can start, valid cut can start from here and can go up to here. Means this is row 0, row 1, row 2. So what actually we can do? So one is possible that if I cut in the row 0, so one section will be this is section 1 and this will be section 2, correct? On a cut actually here, another actually on a cut here in row 1, then section 1 will be this and section 2 will be look like this, correct? So what actually the range? So we can actually explore all this, like for cut actually I can do I is equal to 0, I less than r minus 1, less than r minus 1 means ultimately I can go up to r minus 2. Means I have actually in the first section 1 actually I have only one row, that means this I0, this is only. Next I can actually adding this row again, one more row in the section 1, and this can go up to actually how many rows are there? R value is 3, 3 minus 1, 2, it can go up to 1. So you can see here that I can actually take maximum row 0 and row 1. Correct? This is clear. Now this is for all horizontal cut. Now how you can do the sum of the section 1 and section 2? So I know that it will be always for the section will start from j will start from 0 and j can go up to I and j plus plus, j less than equal to I, and for k will be 0, k less than column, k plus plus. This is for section 1 grid of j comma k. This is for section 1, and another for section 2. This j will be start from I plus 1 and j less than row j plus plus, and for k will be start from again 0, k less than column, k plus plus. In section 2, this is part of section 2, so I'll add this into the grid of j comma k. This is clear, this brute force approach. So for horizontal cut I have already explained the range. So if there is 3 row, so it can go up to row 0 and row 1 in the section 1, correct? Because it should be have non-empty, both the sections should be non-empty, so that's why I have at least one row for the section 2 and at least one row for section 1 also. So that's why I'm starting from row 0. That means this indicate that how many rows are in the section 1. This I is equal to 0, and 0 means the row 0 is part of the section 1, and when I go to the I plus plus, it means I0 and I1 both are actually part of the section 1, and I2 means row 2 is the part of the rest rows are actually part of the section 2. Got it? So for this condition, I will check that that I know that this will start up from this. When I suppose actually have some this row, like I have divided here. So row 0 and row 1 is part of the section 1. So I know that this will be starting from 0 comma 0. This is 0 comma 1, 0 comma 2, 1 comma 0, 1 comma 1, 1 comma 2. So that's why this is starting from always row is equal to 0, means this the section 1 part, section 1 part. So it's starting from 0 comma 0 and it can go up to the I. Row can go up to I, means actually row means 1 0 1. So you can see here that maximum row it is possible 1. Got it? And maximum column is both are same because this is horizontal cut. Correct? So that's why you can see here that j is equal to 0, always starting from the top left, and it can go up to the j less than equal to I, because this I is the part of the section 1, this row. So that's why I can go up to all. I have to add all the elements present in this region, and also column can go up to 0 to k less than c, because column is not affecting anything. So all columns are part of the section 1. So I am adding the sum of j comma k into the section 1. Similarly, for the next section 2 will start from where this I plus 1. This is I. Suppose I is equal to 1. So from I plus 1 to less than r, it will be part of the section 2. So that's why I am starting from j is equal to I plus 1, j less than r, j plus plus. And similarly for k is equal to 0, k less than c, because all column will be part of the section 2. So that's why I'm adding the sum of this, the value of the in this particular index into the section 2. Now after each, now we actually have the section 1 sum and section 2 sum. Now check that if section 1 is equal to section 2, then I will return true. Got it? In this actually I will explore all the horizontal cut. Now we have to explore the vertical cut. So this is brute force approach. Vertical cut means it can go up to similar way. I can be start from 0 and I can go up to c minus 2, column minus 2 total, and I plus plus. Similar reason. Suppose we actually have this 3 cross 3 matrix. So it can be part of this. If I cut here actually, so the matrix will look like, section 1 look like this, and section 2 will look like this. Got it? Now if I cut here, so the section 1 look like this and section 2 will look like this. Got it? Clear? Now what is the maximum row actually I can actually have in the section 1? Maximum column, 2 column. That's why this actually c minus 2, because at least one column should be present for the section 2. So that's why maximum column can be value can be actually, you can say 0 1 2. So total number column is 3. So maximum column is 2, 3 minus 1. So that we have to at least have this column, this column 2 should be present in the section 2. So that's why I will group to 0 and 1 maximum, and 2 will be always part of the section 2. Got it? Now what have to do again in a similar way. So if I cut here, suppose this is our cut, so you can see here that our it is starting from row is starting is constant. Row will be starting on I 0 I less than all all rows are part of this in section 1, this row 0, row 1, row 2, but column had been changed. Column range is only for j is equal to 0 to j less than equal to I, j plus plus. Actually I for this cut the ith value is 0. This column is a part of the section 1, so that's why it will be added to section 1 plus is equal to grid of I comma j. Clear? And similarly for section 2 also, this all rows are part I less than row I plus plus, but column will start from where j will be, the column will start from this I plus 1, sorry, j less than c, j plus plus. That means all the remaining column is the part of the section 2. So I'll add this in the section 2. Now I'll check that again same way. I'll check that this is equal or not. If it is equal, then I'll return true. And ultimately, after explaining all the possible cut, I will ultimately return false, that I have not found any valid cut. Got it? So for this brute force approach, this is clear. Now for the time of study for this algorithm. So first of all, our cut is starting from 0 to r minus 2. Suppose this is the range I can actually do. So this is roughly r times. Now for each cut, I am traversing each matrix, or like whole matrix again. Means I am actually trying to find out the sum of this section 1 and the sum of the section 2. But I am iterating each element of the matrix again. So this will actually take r cross r. Total number of elements is present in r cross column. Total number of rows and total number of columns. This is total number of elements. I am iterating each element at least once for each cut. So that's why the times will be r square into c. Okay. So this is actually almost NQ. Clear? Now this is now let's see that this will work or not. This will not work. Why? You can see here that m cross n is m cross n value is less than equal to 10 to the 5. Plus if we again our times it was what, m square into n roughly. Another is m into n square. But if you can see here that m and n can be 10 to the 5. So but m cross n is less than 10 to the 5. So if I somehow again found any 10 to the 5 m cross n, again suppose 10 to the 5, so it will be 10 to the power 10. So this is 10 to the power 8 greater than 10 to the power 8. So this will give us a TLE. Correct? So this will not work, this brute force approach. Now how can I optimize this? Now you can see the matrix properties of the prefix sum. How? Suppose we actually have this matrix 1 2 3 4 5 6 7 8 9. Now I want to know that from 0 to 0, okay, this rectangle, what is the sum of this rectangle? Suppose I want to know what is the sum of this rectangle. So what actually I can do, I can start from 0 to 2. Again actually I can iterate all the rows, all the columns till this range, and actually I can actually add this into the sum. But what actually I can use here, you can see that suppose that for this row, first row, all the sum will be same. 1 plus, you have to 2 plus 1, it will actually 3. 3 plus, this is prefix sum. 3 plus 3, it is 6. So you can see here that for this, first of all, this rectangle 1 cross 1, the sum is 1. Clear? Next is for this rectangle 1 to 2, this sum is 3. So we are also getting 3 because I know that this current element value is 2 and the the previous index value is 1. So 2 plus 1, it is 3. Next for this rectangle, what is the sum of this? Current element value is 3 and the previous value is 3. So 3 plus 3, I got 6. You can also cross check that the total sum is 1 plus 2 plus 3, it is 6. Clear? Now when you're doing this 4 also, this will be same. So this is clear that this will be 1 3 6. Clear? Now for this 4, this rectangle, what is the sum for this? 1 plus 4, because I know the previous sum is 1 and the current element value is 4. So this will be 1 plus 4, this is 5. Clear? Next for this 7, this rectangle 1 4 7, this rectangle. So this will be, I know that the previous sum is 5 and current element is 7, so it will be 12. Clear? Next, how can I sum of this rectangle? This, 1 minute, just clear this. Okay, 1 2 3 4 5 6 7 8 9. Suppose I want to sum of this rectangle, so you can see here that in this index we actually have the sum of this rectangle, correct? Sum of this rectangle, and in this index we actually have the sum of this rectangle. Correct? You can actually just imagine the image, then actually will be easy to understand. Correct? Now, what is it? We want to know the sum of this rectangle. Means this rectangle. Correct? Now, if I do sum of this green color, this is the sum of 5. Here actually its value is 5, and here it is the for this blue color, the sum value here is the for sum of the rectangle. The sum of this rectangle element is here it is how much? It was 3. Okay. Now you will see that we actually have 8. So we have found 8. 8 plus, if I do this, add this 5 element, so this is 13. But you can check one thing. We actually have added this color, this rectangle, correct, and this element. So we have to completed this rectangle ultimately, this total rectangle, correct. But one thing actually see that this is the common part both actually have this, correct. This section we're actually adding twice. One is in this or in this rectangle, and one for this rectangle. So what have to do? We have to add only one. So I will subtract this sum value. So what have to subtract? 13 minus what is the sum of this? 1. So this is 12. Clear? Why are you subtracting this? Because this is added twice. One for in this rectangle sum, one for in this rectangle sum. So that's why whatever this will be added twice. So that's why I've actually adjusted by subtracting once. So how can I get this? I'll just go to this shift this index. Got it? So here actually what actually getting 5 plus 3, 5 plus 3 minus 1, and plus the current value is 8. So this is actually ultimately 5 plus 3, this is 8, 8 is 15. Clear? 5 plus 3, 8, and current value is how much? This is actually what's the 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is actually ultimately 5. So this sum will be changed to 8 plus 5 is 13 minus 1 is 12. Clear? You can see here that the sum of this rectangle is 12. Sum of this rectangle it is 12. 1 plus 2 plus 4 plus 5. So 1 plus 2 is 3, 3 plus 4 7, 7 plus 5 12. Clear? How to get efficiently without traversing all the elements from here to here. We are not we can optimally actually finding the sum of this rectangle from 0 to 0 to till this point I comma j. Similarly this is actually 12. So similarly for this what will sum for this rectangle, so I know that for this rectangle the sum is 6 and the left sum it is 12. But what I have to do? I have to subtract this because this rectangle actually I have added twice. So minus 3, and that current element value is that is 6. So what is this the total sum? This will be 12 plus 12, it is 24, minus 3 it is 21. Clear? Clear, right? So now go to another example, then it will how it will be using this concept in this problem, then it will help us here. Suppose we actually have 1, 2, 3, 4, 5, 6. So now found out the prefix sum from 0 to 0 to I comma j. So the for the row it will be the same, and the first column also this will be 1, 1 plus 2 it will be 3, and 3 plus 3 it is 6, and this is 4 plus 1 5, and this will be 5 plus 3 plus 5 minus 1, this will be 12, and this is actually for this rectangle 6 it will be 12 plus 6 minus 3 plus 6. So this will be 24 minus 3, this is 21. This is 21. Clear? The prefix sum is clear. You can see that from 0 to 0 from 0 to 0 to 0 to till 0 to 0 the sum is 1. Here it is indicating that from 0 to 0 to 0 comma 1 the sum is 3, and this indicating that from 0 to 0 to 0 to 3 0 comma 3 the total sum is 0 comma 2, the total sum is 6. Clear? Now how can I use this sum, prefix sum, in this concept to optimize the solution? So what actually we can do, our grade card is possible in this matrix only once. This is the only grade, like one possible card. Now we have to check the section 1 sum and section 2 sum. So how will use this? So suppose we actually have this matrix now, 1 3 6 5 12 21, correct? Now this is only one valid horizontal cut. So if I cut this here, so what will be the section 1 sum? So this indicate the total from 0 to 0 to this index, the total sum. So section 1 sum is 6. What is the section 2 sum? This is the total from 0 to 0 to row minus 1 comma column minus 1. This indicating the whole matrix sum. You can see here that this is a total sum from this to this, and this is storing in this index, correct? This is 21 is the total sum of this matrix. Now how can actually get this, the sum of the section 2? So if I just subtract this 6 from here, 21 minus 6, like it will be 15. So 15 is the sum of the section 2, because if I subtract this matrix, this section 1, so what is this is the only rectangle, remaining rectangle will be this. So this will starting from here, and if I subtract from this value, I will get the sum of the section 2. Clear? Similarly, suppose we actually have another. Suppose we actually have 3 cross 3. Suppose 3 cross 3. Suppose this is 3 cross 3. Now first is the one cut. This is first cut 1. So section 1 sum will be this. Suppose sum 1, sum 2, sum 3, sum 4, sum 5, sum 6. So section, if I cut here, the section 1 sum will be S2. Clear? Section 2 sum will be what? S6 minus S2. Clear? Now check that if section 1 sum is equal to section 2 or not. Next, cut actually I can do on this line. Correct? Then what is the section 1 sum? Section 1 sum will be S4, and section 2 sum will be what? Total sum is S6, and if I subtract S4, then actually get this rectangle ultimately. Correct? So now we will check that is section 1 sum equal to section 2 or not. Clear? Now we are not traversing the each matrix every time after each cut. Correct? To get the sum of the section 1 and section 2. Clear? Similar way, for the vertical cut also we can use this concept. Suppose we actually have here. Sorry. So this is our 2 cross 3 matrix. So we actually have sum 1, sum 2, sum 3, sum 4, sum 5, sum 6. Okay. Now I want to cut here, suppose in this line. Okay. Then what will be section 1? Section 1 sum will be S4, because this is starting from here, ending from here. This is actually indicating from 0 to 0 till 1 comma 0. So this is directly S4. But section 4 sum will be what? This is the total sum is storing in S6. What we have to subtract? We have to know for this rectangle only, this section. But if I subtract this rectangle, then actually we get this remaining rectangle will be the we actually want that rectangle only. So this rectangle sum is S4. So if I subtract S6 minus S4, I will get the section 2 sum. Clear? Just follow the actual image, then it will be easy to understand. Just cutting here, and this is rectangle section 1, and this is section 2. So section 1 sum I will directly I am getting from 0 to 0 to till 1 comma 0. Now for this remaining section 2, the sum actually I know that from 0 to 0 till 1 comma 2. But I do know from this only, like 0, 1 to 1, 2, right? But we know that the sum of this rectangle, that is 4. If I subtract this, then you can just see the image only, that we are getting the remaining, that actually we want the sum of that rectangle. So this will be S6 minus S4. Clear? Next is I want to cut here. 1 minute. Sorry, this will be S6 minus S4. Suppose I want to cut here now. So then section 1 sum will be S5 and section 2 sum will be what? S6 minus S5. Clear? I want to know the sum of this rectangle. I actually have this rectangle sum in this index S5. If I subtract this total sum uh, from S6 to S5, then actually get the what is the sum of this rectangle only. Clear? So again, actually it is helping us in vertical cut also. Correct? So it will take what time actually? First of all, when actually calculating the prefix sum, it will actually take big of row close column, because I am iterating each element of the matrix once to get the prefix sum. Now for the vertical cut and horizontal cut, I am exploring each cut. This is R number of cut are possible for horizontal cut roughly, and I am actually iterating. I am not iterating the whole matrix. I am just in constant time and getting the sum of the section 1 and sum of the section 2. So that's why it will be row comma column, because this is for vertical cut, horizontal cut, and this is for vertical cut. So total time will be R plus column to get the prefix sum. After that, this will be number of rows and number of columns. Got it? Now go to the code. If any doubt, any suggestion, you will comment on that. And if not yet subscribed, please subscribe channel. Thank you. And now go to the code. So first of all, found out how many rows are there and how many columns are there in this input matrix. Now I have to calculate calculate the prefix sum. So that's why I have actually again another matrix of prefix for prefix sum. The size will be same and the initial value will be 0. And for the first 0, 0, there is no previous element, upper element, or the correct. So that's why actually this value will be same as the input value. So that's why for 0, 0 index, I am actually storing whatever actually value is present in the input matrix. The first row, there is no element, no rectangle present in the upper side. So that's why I have to do the iterate add from the previous or the left rectangle. So that's why I'm just iterating from I is equal to 0, I is equal to 1, I less than column, I plus plus, and this is for first row only. So that's why row value is constant here is 0 and I is just changing column, and it's starting from 1. And what will be the previous mean the left rectangle value will be, I will get from the previous this prefix matrix 0, I minus 1, and the element of the present the current index grid I, 0. Similarly for the first column also, there is no left rectangle, only we actually have some upper rectangle. So that's why I'm again for row will start from I is equal to 0, I less than row, I plus plus, and prefix sum of this rectangle will be I, 0, because I is just getting changed here. Suppose for this, here actually we don't have any left rectangle, so that's why the sum will be only iterated from the top. So that's why I'm just adding from the prefix of I minus 1, and j will be constant 0. The column is only for the first column and the element present in the current index. Got it? So now actually we have completed the prefix sum of this first row and the first column. Now suppose for this element, now I want to calculate the next for this index. So what will get? I'll get, suppose this is S1, this is S2, this is S3. So what I have to do? I have to do S3 plus S2 minus S1. Clear? And also the grid, the current value I, j. So I have already explained why actually I am doing this, to get the sum of this rectangle. Clear? Now for the next, I am starting from I is equal to 0, I is equal to 1, I less than R, I plus plus, and j column will start from 1, j less than column, j plus plus. And the prefix value of this rectangle from starting from 0 to 0 till I, j, the prefix sum will be prefix of the I minus 1, j, means this this is the I minus, this is suppose I comma j, this will be I minus 1 comma j, this will be I comma j minus 1, and this will be I minus 1 comma j minus 1. So what I have to do, I have to add this and subtract this, correct? So that's a prefix of I minus 1 comma j. This is from the upper side, upper rectangle, and this is for the left rectangle. Left rectangle means I comma j minus 1, and what this will be added, and whatever subtract the I minus 1 comma j minus 1. This I have to subtract I minus 1 comma j minus 1. I'm subtracting this, and also we have to add the current element in this present in the current index plus of the grid I comma j. Clear? Now we will have the prefix sum till from 0 to 0 to I comma j. I can say what is the total sum of this rectangle starting from 0 to I comma j. In any index we can say directly. Now what I have to do, I have to do the operation of the vertical cut and the horizontal cut. Suppose I have explored the first horizontal cut. So again the horizontal cut is valid from 0 to r minus 2, because at least one row should be in the section 2. So that's why I less than r minus 1. So ultimately it can go up to r minus 2. And what is the section to sum 1? It is actually indicating the I comma c minus 1. I've already explained why. This is I comma c minus 1. Suppose I have cut here. Suppose I have cut here. This is the horizontal cut. So this will be the rectangle sum of this 0 comma 0 comma till this. So this will be I comma c minus 1. Clear? This is for section 1. So sum 1 I am actually storing I comma c minus 1, and for the sum of the section 2, sum 2 will be whatever the value is present in this index. I have to subtract this. So that's why here actually what will be the sum r minus 1 comma c minus 1, r minus 1 comma c minus 1 minus sum 1. Clear? Now we will check that if the section 1 sum 1 is equal to sum 2, if it is equal, then return true. If at least one is matched valid, then we have to return true. So that's why I'm returning true. Similarly, after explaining all the horizontal cut, we have to explore the vertical cut also. So vertical cut range will be same. 0 from 0 to c minus 2. So that's why it is number of columns minus 2. So again, how is it getting the prefix sum? Suppose we are cutting here. This is the vertical cut I have done. So this will I will get the one sum here, sum 1, and this is the sum 2. So this is the rectangle sum of this cut section 1. So this will be what? R minus 1 comma I, last row and the first column. Last will be constant, because I know this will be always the ending of this rectangle. So that's why the sum 1 will be prefix of row minus 1 comma I. I means how many rows are there. And sum 2 will be what? This is the total sum S2. If I subtract this rectangle, I'll get the remaining rectangle, this rectangle, I'll get the sum of this rectangle. So that's why S2 minus S1. Got it? So that's why I'm just, whatever the actual value is present in the R minus 1 comma C minus 1 minus sum 1. Clear? Minus sum 1. And I will check that if it is sum equal, then return true. After explaining all the vertical cuts, if there is no match found, valid cut, so ultimately would return false. Correct? The default answer will be false. So I hope this is clear. I have shared this code in the description. You can check that. Okay, thank you.